Okay, so in this video, we're going to talk a little bit more about angle measurements kind of in the coordinate plane. And we're also going to look at a new way to measure angles, and that's with radians. Um, but to start, how we measure angles in the coordinate plane typically, and the way we're going to do this for the rest of our chapter, and you're going to do a ton of this in pre-calculus and in calculus, is you kind of let this beginning side or the initial side be the positive x-axis, and then your angle goes out from that counterclockwise. So wherever your angle finishes, we call that the terminal side. Um, so if we want to draw an angle of 210 degrees in the coordinate plane, what we're doing is we're starting with this horizontal line over here and then going over 210 degrees. Well, 90 degrees is vertical, 180 is flat, 210 is about a third of the way down here. So something like this. This angle would be 210 degrees. Now, if you have a negative angle, instead of going counterclockwise, you just go clockwise. You kind of go down from the x-axis. So 45 degrees down would be like this. It's negative 45. For 510 degrees, if you think about this, you're starting here, you're going all the way around for 360 degrees, and then you have to figure out, well, how many more degrees do I have? So we got 90 more. Well, let's figure this out. 360 from 510 is 150. So after you go around once, that's 360 of your degrees. You need 150 more, which is somewhere around here. We're just getting a sketch. So really what this angle did is it went all the way around and up. Now, you do not need to put this little spiral, but I'm just kind of showing how we did that. I didn't do this part. Tell which quadrant the terminal side lies. What quadrant is this in? This is quadrant 3. This is quadrant 4. And this is quadrant 2. Remember, quadrants are 1, 2, 3, and 4. So we're pretty comfortable with degrees. Everything we did in geometry class was degrees. But for a lot of higher level math, we actually don't like to use 360 degrees. We like to give our angle in terms of pi. So a radian is measured in terms of pi. So one full circle equals 360 degrees. And here's our new thing, 2 pi radians. And where this 2 pi comes from is because if you have a circle, the circumference of a circle is the distance all the way around, or how far all the way around it is. If the radius is 1, the circumference is 2 pi r, so 2 pi 1. So all the way around is 2 pi. That's where that comes from. And so you're kind of measuring, in a sense, this length. That's not technically what we're doing. We're measuring an angle. But we know from geometry, maybe you forgot, that an arc measure like this is the same as the central angle there. It's totally okay if you forgot that. We're really not going to be using a ton of that at all. But it's just another way to measure angles. It's just like degrees. So just like distances can be measured in feet, inches, and miles, degrees or an angle measure can be measured, in degrees or in radians. So it feels weird just because you're not used to it. So if you were told like a full rotation on a snowboard is 2 pi radians from birth, you wouldn't think that's weird. You would think degrees is weird. And this is a little side note, but we picked 360 for degrees. That was like a human construction, and we did that because 360 is divisible by like a ton of numbers, like 2, 3, 4, 5, 6, 8, 10, 12. Just a bunch of different numbers go into 360. So that's why we picked it. Okay, moving on. How do we work with radians? Well, 0 radians would be at 0 degrees. 90 degrees, if you want to think of the entire rotation as 2 pi, we could think, well, half of it is 1 pi. So 180 degrees compares directly to pi radians. 90 degrees refers to a half pi, or we like to write that as pi over 2 radians. And 270 is a half pi more than pi, which is like 3 halves pi, or 3 pi over 2. And then we're going to get other angle measures kind of inside there, but these are your angles on the axis. So to convert from radians to degrees or vice versa, we just have a couple different quick little formulas. It's not really a formula, it's just what you're going to multiply by. So if you ever want to change degrees to radians, you're going to want a pi on top. So you're going to multiply by pi over 180 because there's 2 pi's in 1 360. So if you want to take 200 degrees and figure out how many radians it is, you just take 200 times pi over 180. And typically we don't estimate this. We would just simplify the fraction of 200 divided by 180, which is like 20 over 18, which is like 10 over 9. So 10 pi over 9 radians. Negative 45, we can do negative 45 times pi over 180. 45 goes into 180 4 times, so this is like negative pi over 4. Negative pi over 4 radians is the exact same as negative 45 degrees. To convert from radians to degrees, you just multiply by the reciprocal. I like to think of this as, well, there's no pi in radians, so we need to cancel out the pi. So we do 180 over pi to simplify. So your pi's basically cancel, and then it's what's 3/5 of 180, and you just get like 108 degrees. Negative 2.25. Now that doesn't have a pi in it, so we're going to take this times 180 over pi. So it doesn't simplify as nicely, so you're going to want a calculator probably. I'll do this really quick. You get about negative 128.92 degrees. So that's just your quick way to convert from degrees to radians. When we work more in chapter 13, we're going to get pretty quick at doing some of the more common angles. It's pretty rare to have to do like a negative 128.92 degrees, but that's just showing you that you can do it for anything. So we talked about pi over 2, we talked about pi and 3 pi over 2. You can also break all of these down within. So like 45 degrees is half of 90. So instead of pi over 2, you'd get pi over 4. For 60 degrees, that's like 2/3 of 90. So 2/3 of pi over 2 is pi over 3. 30 degrees is 1/3 of 90 degrees. So you take pi over 2 times 1/3 and you get pi over 6. And you could do something similar for all of those. This is kind of going to be our introduction to our unit circle, which we're going to talk about in 13.3 and 13.4. So today we're just going to sort of leave this, but as the days progress, we're going to build on this picture with some points as well. So the last thing we're going to talk about is this idea of a coterminal angle. So we saw back on the first page that 510 degrees, you did a full rotation, and then we went up to 150. So with that in mind, what's there to differentiate the difference between 510 degrees and 150 degrees? They would have the exact same terminal side, and the picture would look the exact same. And in reality, there's really no difference between them. And that's what a coterminal angle is. It's any angle that is the same as another angle, just written a different way. So to find these coterminal angles, you can add or subtract 360 degrees as many times as you want. Or likewise, if you're working with radians, you can add or subtract 2 pi as many times as you want. Every angle has an infinite number of coterminal angles because you can just keep adding or subtracting 2 pi. So for example, if you want to find like 2 different coterminal angles of 420 degrees, you could subtract 360 and you'd get 60 degrees. You could add 360 and you'd get like 780 degrees. And if you were to take like the sine of 420 degrees and compare it to the sine of 60 degrees, you get the exact same number because they are effectively the exact same angle. It's just taking a loop around, which doesn't really matter. To add or subtract 2 pi, you obviously need a common denominator. So if you have something like 17 pi over 4, you could think of adding 8 pi over 4. Now, I did that just to get a common denominator. I know 8 pi over 4 is the exact same thing as 2 pi. You could also subtract it. So 2 different coterminal angles here would be like 9 pi over 4. Or if you add it, you'd get like 25 pi over 4. So that might be a little more foreign to us, but it's the same idea as adding or subtracting 360 because 2 pi is 360. It's just we would need a common denominator if we were going to do it without a fraction. And that really wraps us up for 13.2. So it's just some new vocab and a new way to look at angles.